All right, y'all get out number 47 from your ACT. We are not coloring today. Hey, Grayson. Hello. All right, guys, y'all got number 47. We're going to go over whatever ones that you need, okay? What? Alright guys, y'all got number 47 ready to go? Come on, let's go. Oh. All right, here we go, guys. What about number 47? Uh-oh. Yeah. Yeah? 3 days in a row? Yeah, we need to go over 47, you said? Okay. All right, let's see. Let me get my cursor to work. Okay, 47. So, do you remember probability from, like, way back when, and it said the words and or? Remember those and or problems? So, what does and mean to do? No. Get off of your phones. We are on number 47. Pay attention, learn something, be somebody, and go somewhere with your life, okay? What does and mean to do? No, that's what Matthew just said. There's only 3 more left.
Divide.
No.
Multiply.
It means multiply. Or meant to add. So and means to multiply. Or means to add. Okay, this said and. So if it says and, which one has the multiplication? Yay, D! There we go. Come on, wake up. Let's go. Come on, come on, come on.
Wait, what did you say?
Huh? What, Mike? Okay.
So how will we figure it out if there's 2 answers in multiplication?
It
Wait,
won't.
there is 2 answers.
No, there's not. The only one that has just multiplication, because all it said to do was and, was this one. It's the only one.
No.
It's giving you all this mumbo jumbo stuff, and all it wants you to do is remember the operations with and or. Okay? And means multiply, or means add. All right, what about 48? Do we need to go over 48?
Yeah.
Yes? Okay. So this is the stuff that we're going to learn in 4th quarter. We haven't learned it yet. So you see this little triangle that I drew right here? Okay. So you have an x, which is 4, and you have a y, which is -3, okay? So if the x is 4, which one of these lines is the 4?
Wait, say that again. Sorry.
If x is the 4, which one of these lines is 4? The one on the x-axis, right? Okay. So if, hi dear, thank you, ma'am. All right. So if -3 is my y, which one of these two is the -3? Huh?
The one going up and down.
The one going up and down, which is like the y-axis. So this one is -3, right? So the reason that it's negative is because it's going down below the x-axis, right? So pretend like the negative's not there. You have a triangle that you know in geometry. When you had a 3 and a 4, what's the other side?
A
what?
A 2.
A 5, Chloe. Very good. You had a 3, 4, 5 special right triangle. If it's a special right triangle, now it's said to do, what did it say? What is the cosine? Here we go. So cosine, remember SOHCAHTOA? All right, cosine is adjacent over hypotenuse. So we want this angle right here. What's the adjacent? What's the one right next to that angle? 4. Why did we not use 5? Because 5 is what? The hypotenuse. So this is 4 over 5. Very good. Y'all okay? All right, what about 49? Do we need to go over 49?
Is it C?
It is A.
Yeah. Wait.
All right, let's talk about how to narrow down answer choices first of all. You ready? Number 2, is that answer always going to be positive or always going to be negative? Which one? Always going to be positive. What about number 3? Is that answer always going to be positive or always going to be negative? Are those two ever going to be the same? No. A positive and a negative, or no matter what number you plug in, they are never going to be the same. So any answer choice that has 2 and 3 together, we can mark out which answer choices have 2 and 3 together. C and D. And we know that at least something's going to be equivalent, right? Because if we square root a number in real life, remember this in your project when you square root numbers, what's the only part of that graph that you see? The positives or the negatives? The positives. Remember that graph looked like this? This part of your project? And the only part that you see is the positives? I just helped you out a little bit on your project. So which two are the ones that will, no matter what number you plug in, will always be the same kind of answer? 1 and 2, which is A. Does that make sense to everybody? Yes, sir.
Well, that square root, doesn't it cancel out the power of 2? So then you're just left with negative x.
Yes and no. You try and remember you have to do the order of operations. So if you plug in a number, plug in any number you want. Let's plug in 7, okay? So I do the square root of negative 7 squared. So do this first. What's negative 7 squared?
49.
So what's the square root of 49?
Plus 7.
Technically, it's plus and minus, but when you graph it, the minus side is undefined. So the only part that it's wanting you to look at is the positive side, which is positive 7. Okay? I did the same thing, and I picked B at first, and then I went back and looked at the answers, because I thought my same process, just like you are doing right now. And then I was like, oh crap, that's not the answer. Then I was like, let me plug in a number. And when I plugged in a number, it worked. That's why. Okay? It always helps on these to plug in numbers for me, especially. Because, yeah, I definitely picked B when I first did this. Because I had that same process. All right, what about 50? We need to go over 50? 50 was K. Do we need to go over 50? Yes? Okay. Okay, what do we know? It says it wants to know which ones are not going to be the same. Okay, so here we go. So let's see if this is true. AB is parallel to EF. So this line right here, AB, is parallel to EF. Are those parallel?
Yes.
How do you know that?
Because they both have right angles.
Both have right angles, which means they're both vertical. There you go. So that is justifiable. That I can prove. All right, what about G? DE, this line right here, is perpendicular to this one.
Because they intersect.
Not because they intersect. How do they intersect?
Right angle.
With a right angle. That's the definition of a perpendicular, is because they intersect with a right angle. So those are perpendicular, okay? Angle ACB, this one right here, and FCE, this one. Are those congruent?
Yes.
Why? Because they're vertical angles. There you go. So I got to find the one that's not justifiable. So triangle BAC, this one right here, is similar to EFC, this one right here.
I said no.
They definitely are. How?
They're both right triangles.
Not because they're both right triangles. Remember the angle, side, angle, side, 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 angle, side, all that stuff from geometry? Okay, they have an angle that's the same. And since this side is a right angle, this side is a right angle, right? So those two angles are the same. And if that's true, they have these sides. This is angle, side, angle that they're congruent by. So they are similar triangles. What's the other one left is...
It's going to be K because EF divides it in.
Okay, well, let's look and see. CE is this one. Oh, okay, because in order for these two sides to be the same, these two angles have to be the same, and you don't know that that's true. They could be, but you don't know that they're the same. So it's got to be K, because they don't give you enough information to figure out if they're the same. You know these two are the same, but you don't know these two are the same. All right, so tomorrow we're going to look at 51 through 55, right? You got it good? And then, like, we'll be finished with these, like, by next week, and we'll be starting another one. Juniors, probably next week, we'll do our first little ACT prep thing, right? And we'll look at those, okay? Does that make sense to everybody? You got it good? All right, here we go. So, here's what we're going to do today. Today, we're going to finish the rest of 7.8 notes. So, if you grab those, you need a graphing calculator or some kind of a calculator to do calculations for you. Not necessarily graphing, but you need some kind of calculator to do calculations for you. All right. Are you ready? So we finished the front part yesterday, and now we're going to go to the back. Here we go on the back. Let's see. Leonella, can you read us just number 3, please, dear? Okay. It's page 10.
Number 3?
Yes, ma'am.
In 2007, the population of China was 1.32 billion. In 2000, it was 1.26 billion.
Perfect. All right, Diego, can you tell us what it's wanting us to do in part A? Read part A, baby.
It's asking us to determine what the value of K is.
Okay, so if it's asking us to determine what the value of K is, then K is our unknown, right? So guys, it'll make your life so much easier if you list your givens first, okay? So if you're taking physics right now, that's like the first thing that you're supposed to be taught how to do is list your givens. So now we got to figure out what formula are we using? What formula are we using? Growth or decay, and how do you know that? Growth, how do you know that? Because it says rate of growth right here, okay? Okay, so on the front, your formula for rate of growth, for let's do this for our memory's sake, was f of x equals a e to the positive kt power, right? So we know that k is our unknown. What about t? What about time?
7 years.
How'd you get that?
2000 to 2007.
There you go. All right, let's see. We know e is the 2.7818 or whatever it was. I can't remember what it is. And then we have a is our initial amount. What is the initial amount of China's population?
1.26.
1.26 billion. Very good. And f of x, or y, is your final amount. It's the amount that you have your growth to. What's the final amount that they want to grow to in 2007? 1.32. There you go. So we have 1.32 is equal to 1.26. E to the k is my unknown times t is 7. Y'all okay? All right, what can I do? Divide. And when I divide 1.32 and 1.26, does that divide evenly? No, it doesn't. All right, so let me see. I'm going to do 1.32 divided by 1.26 equals e to the 7k power. All right, all right, all right. What's the opposite of the e? How do you get rid of it? Natural log. Very good. And that natural log and that base e, that natural base e, will cancel out. So you have the natural log of 1.32 divided by 1.26 is equal to 7k. And then one last step. How do I get rid of that 7 with the k? You divide. Okay, so let's make sure we plug it in right. Natural log 1.32 divided by 1.26. Close your parentheses. Hopefully you're plugging this in your calculator. Half of you aren't. My job is not to do the work for you. And then what do we do when we have that? Divide by 7. And what'd you get? 0.007, you said? Okay. Y'all okay? So K is a rate. So when you use it in your formula, you have to use the decimal. But when I talk about it in my answer, I have to have it as a percent. So how much is that as a percent? 0.7%. Very good. We move that decimal 2 places to the right. All right, so let's make a sentence. What can we do for a sentence?
China's. Yeah.
China's population grew about 0.7% from 2000 to 2007.
Very good. Guys, make sure you put the years in there, okay? Because their population is not always going to grow the same amount, right? But it grew 0.7% during those 7 years, okay? All right, what about part B? Josh, what does part B tell us to do?
When China's population will reach 1.5 billion.
Okay, when will. What does when will mean?
Equal.
What? It's the T. The time is what I don't know, right? Bless you. Okay, so what is my K then?
0.7%.
No, it's not. 0.007 is what you have to use when you plug into your calculator, okay? All right, what about my A? What's my initial amount of China's population? 1.26 billion. Then what's my F of X or my Y? My final growth that they want is 1.5 billion. Let's see what happens. So what's the reason of having to learn how to do these formulas? Like, why in the world would China even care about figuring out what their population would be?
Housing and food.
Hunger Games.
Stuff.
What did you say? Really, Matthew?
That's it.
So,
They have a
Scotty,
population problem,
so we need to figure out about housing. We need to figure out about if we need to make our streets bigger. If you notice on 65, like on the, what do they call that? The malfunction junction. Isn't that what they call it? Okay. You notice how they've been, if you've been that way, they're making a whole new intersection to come on. It's because we've got a lot of traffic coming in. Those are things that you've got to figure out based on your population, okay? You've got to figure out how to put more houses in. You've got to figure out how to put more roads in. All that kind of stuff. Okay, so here we go. So f of x is 1.5. A, my initial amount, is 1.26. And then e to the 0.007t. All right, what do I do first? Divide. Does that divide evenly? Probably not. No, it doesn't. 1.5 divided by 1.26 equals e to the 0.007t. Now what do I do?
natural law.
Natural log. Very good. Yep, double sign. I just noticed that. Bless you. Y'all okay? All right, now what would I do? Divide. Very good. So natural log of 1.5 divided by 1.26, all divided by 0.007 is equal to t. So how long is your time before
24.91 years. So 25 years.
24.908 is what I got. Yep. Y'all okay? Yeah, do 3 decimals, unless you're talking about money. Okay, so let's write a sentence. What can we say?
China's population will reach 1.5 billion people in about 25 years.
Very good.
You know that one-child rule that they have in China because of their population being so large is working.
Well, that's communism. That's communism for you, dear. It's a whole different beast.
But it's working.
China population reached 1.5 billion. Well, that would work on a whole different level too, but we're not going to go there because a lot of other things could control their population, but they're not really ethical or moral or a lot of other things too. Yeah, they used to kill the female child too to keep their population down.
Yeah.
Yeah, that's why you don't live in a communism state. Here we go. Well, China's population will reach 1.5 billion people in about 20, yeah, it is about 25 years. Y'all okay? You got it good? All right, let's look at the bottom one. Number 4, 5, and 6 is talking about your money, right? We all like money. Got it good? Mm-hmm. So, let's talk about some money. We're going to have to look back on the front. So, number 4, let's see. Sarah Avery, can you read us number 4, please, dear?
If interest is compounded continuously at 4.5% for 7 years, how much will a $2,000 investment be worth at the end of 7 years?
Okay, so basically it's the same thing, but how is your interest compounded? What does it say? Continuously, right? That means every time that you have a new month or a new quarter, however they're compounding it, every time they're going to add more percentages to your money. So look back on the front. Let's see. Do you see these 2 formulas right here? The only one that we're going to talk about is the continuous compounded, which is A equals P e to the RT. Basically the same exact thing, right? What is the initial amount this time? Still in the same place, but what letter are we calling it? It's P. It's still in the same spot. What is the amount, the final amount at the time they give you? What letter is that? That's A. R is still the interest rate, correct? It's still a rate. And the T is still the time. Does that make sense to everybody? All right. Same thing, basically, just different letters. All right, so what is my P? What is my initial amount? 2,000 was the amount that you're going to invest. What's my time? 7 years. What's my rate, my percent? Very good. Even though it is already a decimal, It is still a percent. You have to move that decimal 2 places to the left, which would give you 0.045. Very good. That's a huge mistake. Bless you. Bless you. That's a huge mistake people see. They're like, oh, it's already a decimal. Yeah, it's already a decimal, but it's a decimal percent. It's 4.5%, okay? What about the A? What's the final amount at the time of 7 years? We don't know it. There you go. So this one's pretty easy. A equals 2,000. E to the 0.045 times 7. And you can plug that all straight into your calculator. You ready? To be 2,000. Where's the E button? On the natural log, because it's the opposite of the natural log, right? So that's why everything is on the same button. And then you can do 0.045 times 7. If you have the old calculators, which are not updated, just use parentheses around the 0.045 and a 7, and you can still plug it all straight in. What'd you get?
2,740.58.
Well, we're doing with money, so how many decimals we're going to do with money? 2. So it'd be 552, right? So what is the amount of money at the time of 7 years?
2,740.52.
There you go. Got it good? So basically you made $740.52 in 7 years without doing a daggum thing but putting your money in the bank. Does that make sense to everybody? Okay. Not the sentence that I just said. Don't say that. We could say that at in 7 years, at 4.5% interest, our initial investment would grow to 2740.52. I can't fit all that on the screen at the same time. All right, number 5 is the exact same thing, but you got to use your noggin. You ready? Chloe, can you read us number 5, please, dear? Okay, what's the formula I'm going to use, and how do you know it? Anybody? Huh? Compounded continuously, right? Because it says it right there at the end. All right. So let's do the easy ones. Easy one is my time. What's my time?
It's the unknown.
The unknown, right? The X. So what about my K, my rate, my percent? 3%? Very good. 0.003. Perfect.
No, I think it's 0.03.
1, 2. It is only 1 0. Scratch that.
I know.
Right here, baby. It's the percent. Oh gosh, yes. I'm sorry. I put a K. No wonder you were confused. I'm sorry, dear. I'm still doing the other problems. Same thing. They're both the rate. They're just using a different letter. All right. What about my initial amount? What's my initial amount? 3,000. And what about my A? What's my A? Bless you. What's my final amount at the amount? How'd you get that? Because it says doubled. Bless you. Okay, so here we go. 6,000 equals my initial amount, 3,000, and then e to the 0.03t. What do I do first? Divide. And when you divide 6,000 by 3,000, you get 2. E to the 0.03t, and then you do the natural log on both sides to get rid of the e. So you got natural log of 2 equals 0.03t. And then you would divide. And how long is it going to take your money to double at 3%?
23.105 years.
105 years. So it will take about 23 years for your investment to double? I really don't want to wait 23 years, but I'm doing absolutely nothing for my money to double, right? What's wrong with this? Why is it taking so long for your money to double?
It's a low interest rate.
It's a low interest rate. Very good. So, when do you want your interest rate to be high? When you're borrowing money or when you're investing money? When you're investing. When they're giving you money back, you want the interest rate to be high. Now, credit cards, ladies and gentlemen, have a very high credit limit, or not credit limit, excuse me, they have a very high interest rate for people that either, one, go past their promotion period. Like, have you seen on commercials where, like, Capital One will run, like, 12 months no interest, right? Okay, after that 12 months, they're going to charge you, like, I think it's like 27% that they charge interest. It's ridiculous, okay? So, when you get a credit card, after that 12 months, you want to transfer that amount to another credit card, okay? You want to transfer it so you don't pay any interest. Does that make sense to everybody? Got it good?
It sounds like fraud.
Or, no, it's not fraud.
It's not
No, it's called smart, being smart.
true.
Okay, most of the time they'll charge you like a 2% fee to transfer it, but it's still much cheaper than doing the 27% interest. Yeah. When my husband and I take trips, that's what we do. Like when we take a big trip, we'll put it on a 0% credit card, and you just have to be careful and watch it. It's called being smart with your money. And once it gets to that point, you get a new credit card, and you transfer it, and you get 0% interest for however long, and you shut the other one down. And then you keep doing that until you pay it off. But if you don't pay attention to it, they're going to charge you 27% on like $5,000 or $6,000, whatever it took you to go on that trip. And you're going to be
That's a big trip.
up a paddle without a creek. Yep. So, anyway. All right. So, here we go.
Up a paddle without a creek.
Up the creek.
Up a creek without a paddle.
You said up a paddle.
Oh, whatever. It's all right. It's too early in the morning, and I haven't had any caffeine. Y'all, I cut out caffeine, and it's killing me.
I'm sorry for your loss.
You're sorry for my loss. I'm sorry for my loss. All right. So, did we write a sentence for number 5? We did. Now, let's look at number 6. You ready? Here's another life lesson, number 6. Dee, can you read us number 6, please, dear?
A bought a used car for $2,500. It is expected to depreciate at a rate of 25% per year. What would be the value of the car in a year?
Ooh, okay. So let's talk about this word. What does that word mean, Matthew? It means go down. But there's a special word, depreciate, we use instead of going down, because depreciate means that whenever you have bought something brand new, whenever you buy something brand new, it has never had an owner, right? But as soon as you buy it, it has now had one owner. So as soon as you buy it, it is now a used car. It goes down in value. As soon as you buy a diamond ring or a pearl necklace or whatever kind of jewelry you're going to buy that's real, it now has one owner. So it is not the same full value. Does that make sense to everybody? So guys, before you buy her that diamond ring, you better make sure that it's going to be the one that you want, because you ain't taking it back for the same price that you bought it for, okay? Y'all good? Okay. Now, let's talk about cars. You ready? When you go to buy a brand new car, when you get your good job, because you're going to make a good score on the ACT, and you're going to go to college, and you're going to get a good job, right? When you get a good job making good money, you're going to go buy a brand new car eventually, right? Eventually, sometime in your life, you might buy a brand new car. Might. Or if you don't buy a brand new car, you're going to buy a used car at some point. Sometime you're going to buy a car. So, here's the deal. You ready? They will try to make you buy. Are you listening to me? Or are you running your mouth? They will try to make you buy a car and have a loan for a very, very long time. Right now, they're trying to make you have a loan for 7 years. You do not want to buy a car and have it loaned that long of a time. Because what happens when you drive it up the lot, let's say you just bought a brand new car. Shh, let me finish, please. You buy a brand new car. I gotta start back over because I don't remember where I was. You buy a brand new car and you drive it up the lot. I don't know, maybe a month goes by, maybe 6 months goes by, maybe a year goes by, and you get in a wreck, like a bad wreck, and they total it, right? And you have bought that car for 7 years. Your car is not worth the same amount that you purchased it, right? So when you wreck your car and they total it, guess what happens? They do not give you the amount that you need to pay off your loan. They only give you the amount that it's worth. So now you are stuck paying for a car payment that you no longer have. So, one of two things need to happen when you buy a car. Either one, you need to buy a car that you can make a payment on, like a good payment on, and you don't need to buy it over like 7, 8, 9, 10 years. Does that make sense? Two, you need to buy a car that will hold its value. What kind of cars hold their value like extremely well? Does anybody know?
Jeeps.
No.
No.
Yes, they do.
Toyota has the highest, that's why Toyotas are so popular, because they are the most, what's the word I'm looking for? Like, they hold their value the most, is what I should say. And I have another one they know of?
Chevy.
Hyundai and Honda are the next ones, and then I think Chevy might be the one after that. But like your sports cars that you have, like if you want to buy an Infiniti or anything like that, they do not hold their value as well, okay? So if you buy a car like that, what do you need to do? You need to put a big down payment on it, right? So you don't have to finance so much if you want to have a car like that. So you need to have a really good job. You good? Does that make sense?
Listen, Miss Blackman,
What, baby?
when I get ready to drive,
You just come see me, baby. I'll come help you. You come help me. Look, I got my car so cheap because he forgot that I was a math teacher apparently when I told him that. And he tried to do all these calculations in front of me, and I'm like, did you miss the part where I told you I was a math teacher? And you just did that calculation 3 different ways, and you still gave me the same answer? So he went and saw his boss and gave me a good deal. Anyway, let's look at number 6. Bless his heart. I know. He went real quick like to his manager. So depreciate would mean growth or decay. What would that mean? That would mean decay. So the only thing different about decay is the negative. So you have AE to the KT power, right? All right, here we go. What is my initial amount that we bought the car for? $2,500, okay? So let's see. K is the rate, which was 25. Good grief, 25%. Good Lord, you didn't. That is no. That is not a good interest rate at all. It's a cheap car, but it's not a very good interest rate, which means somebody doesn't have good credit.
That's not an interest rate. That's a depreciating rate.
Oh gosh, that is a depreciating rate. That is right. That's even worse. So let's see. Time is 3 years, and f of x is the part that I don't know, right? I want to know how much is it going to depreciate. So here we go. F of x equals 2,500 e to the negative 0.25 times 3. Good grief. That's going to be a good amount of money. 2,500 e to the negative 0.25 times 3. No.
This is going to be a little.
I got 1,180.92. Did y'all get that?
Can we put Y? Probably not. That's a wrong motion.
What do you mean, y? F of x and y are the same thing, Bobby. You can put y if you want to. Same thing. Okay, so in 3 years, your car is worth over less than half of what it used to be. In only 3 years, okay? And in only 3 years, if you've done a 7-year loan, what's half of 7 years?
3.5.
3.5, right? So your car, if you were to wreck it, you're not going to get the same amount of money because it's already less than half of what it owes, and you haven't even paid half yet because you haven't paid 3.5 years yet. Do y'all see what I was talking about? Yes, no, maybe? Okay, here we go. That's also why they make you pay gap insurance, which we ain't going to do. So we're not going to get into that whole thing right now. So let's look at page 7 and 8. 7 and 8. We need to have those finished by Friday. Page 7 and 8. And page 7 and 8 and page 4 and 5. Okay, here's what we're going to do for the rest of the class period. You get to work on this study guide. What do y'all want to work on a study guide tomorrow? Because we're going to have a test Friday, or do you want to do a Kahoot game, which is the same thing? What would you rather do?
No, can we play trash ball?
No. Because I've already spent my time making the Kahoot. So, would y'all rather just do the review, or would you rather play Kahoot? What would you do? Kahoot? Okay, if you would rather just do the review tomorrow, then we're just going to put everybody that wants to do the review in the back of the room and everybody that wants to play Kahoot in the front of the room, and we'll just do it that way. Okay, does that make sense to everybody? You got it good? Okay, cool. Same problems and all that good stuff. All right, your review is on page 11, which is right here. The key will be there tomorrow whenever we play Kahoot game or whenever we do the review. And your test will be what day?
Friday.
Friday. Which means if we're taking a test on Friday, what else is due on Friday? No. Checkpoints and what else? Pages 4 and 5 and 7 and 8. The homeworks that you've had all this week, right? Those 2 pages. 4 pages technically. You got it good?
Yep.
So what's due on Friday again?
Checkpoint.
Checkpoints and homeworks. Okay, go. Yes, ma'am.
I need to see like everything that I've missed because I have a 0 in sports.
Okay.
Nothing here.